right, thank you for not leaving after the Mega ETH talk. So I'm Larry. I'm building a new decentralized exchange called Dango. So the question you may have is, why do we need yet another DEX when we already have so many? Well, the answer is we noticed there is a very basic feature that is not very well supported by DEXs, and that is margin trading. So margin trading is a very powerful primitive. It can magnify your gains or losses and can allow you to hedge your positions. It is literally $1 trillion industry in TradFi. You can do that very easily in centralized crypto exchanges, but somehow you can't do that very easily in DeFi. And now you might say that's nonsense. We have lending protocols like Aave and Compound, which are literally built for this purpose. So let's think about how you can realistically do margin trading in DeFi today. So let's assume you are bringing $100 worth of initial investment and you want $300 worth of exposure to Bitcoin price. So what are your options? Well, as said, the first option you have is to use a traditional lending protocol like Aave or Compound. So you bring your $100 to Aave in the form of WBTC, you deposit that, and you proceed to borrow some stable coins. And now you realize your first problem, which is if you look at Aave's front end, it says the max LTV of wrapped Bitcoin is 73%. And that means for every $100 worth of Bitcoin collateral, you can borrow up to only $73. So you borrow up to $37, you swap that to WBTC, that gives you $173 total of exposure to Bitcoin, or in other words, 1.73x leverage, which is quite a bit lower than your desired exposure of 3x, which we set forth in the previous slide. So what are you going to do next? Well, you deposit your WBTC again into Aave, borrow more, swap, deposit, repeat. And if you repeat this 3 cycles, you are finally able to achieve a 3x leverage. Which, needless to say, it is too difficult for 99% of the users, and the gas cost is just going to be insane. So that's your traditional lending protocol. What about perps, right? The main problem with perps is really, really expensive. So I took this slide. Well, I took these screenshots when I was making the slide, and at the time, the funding rate for Bitcoin on Hyperliquid is annualized to 63.54%. And remind you that if you take a 3x position, you're going to have to pay 3 times that. So for $100 worth of your initial investment, you're going to pay $187 just in fees for holding a 3x long Bitcoin position for a year. And if you compare that to borrow on Aave, which you only have to pay $20 for holding that position for a year. And that is just difference between night and day. And I'm going to quote the founder of Camino, a lending protocol on Solana. So he did some number crunching. That is the total cost for holding a 2x long SOL position for a year. And the lending protocol, which is the orange line on the bottom, and you can see it stays pretty flat, like it's oscillating between 10% to 15%. It's pretty stable. But the 2 lines on the top are perp protocols. And as you can see, as soon as we kicked into the bull market mode, the number just explodes, right? And he moved on to see, well, let's assume the funding rate is 50%, right? And you hold that position for a year. You better hope Solana goes up a lot, because if Solana goes up 50%, you are barely breaking even just from the fees. So perps, I think, is not economically feasible for long-term holding. It is good for some purposes. It is good for long-tail assets. It is good for assets that are not tokenized on-chain. You only need an Oracle fee to list any asset in perps. It is very good if you want to take crazy high leverages, because to liquidate a perp position, you don't need a real asset. So they can give you very high leverages that margin protocols cannot. But other than these, I think margins are better. They are better for blue chip assets that are more liquid. They are better if you want to hold only moderate leverages. You don't want to go crazy degen. And it is good if you want to hold your asset, your positions longer than a few days. So these users on the left, they are very well served by protocols nowadays. But these users on the right, they are not very well served by DeFi today, as we have demonstrated. So these are the users of our, well, this is our initial target user group. We're going to plant our seeds among these users and grow from there. That's our strategy. So how does Dango solve the margin trading problem? Well, if you look at the traditional lending market, what happens is if you want to borrow USDC against Bitcoin, you have to lock up your BTC in that lending pool. And only after that, you can borrow USDC into your account. And that just doesn't make any sense. If you want to trade Bitcoin, why would you lock up in a vault, right? So we created a new DeFi primitive called the margin account. So when you borrow against BTC, you leave your BTC in your account. It doesn't get locked up in a lending pool. So let's imagine you start with $100 of BTC. What you're going to do if you want to take a 3x position on Dango? Well, you just go ahead, borrow $200 from the lending pool, swap $200 into BTC. Now you have $300 of BTC backing $200 of debt, and that's an over-collateralized position. And in just one step, you have completed your position. And just as easy as that, we solve the problem. So now you might ask, wait a second, if you have your BTC in your wallet, how do you prevent somebody just sends that away and just run away with the money, right? To answer that, we have to talk about our infrastructure. So we're not building on EVM, we're not building on Solana or Move. We own our own infrastructure. I named that our infrastructure Grag, which is after the caveman meme because I think it's funny. So this is our tech stack. We are a layer 1 chain. We have Grag execution layer running on top of Tendermint consensus. We have Hyperlane for bridging. We have Pyth for Oracle. We have an extremely fast Oracle updated every block or 0.5 seconds. So just a little bit of thought on infra before moving into it. I think there are 3 dimensions you can optimize an execution layer. That is throughput, just raw TPS. There is security, and there's features. I think realistically, it is not possible to optimize on all 3 fronts. You gotta pick one or pick 2, right? I don't believe Grag is ever going to be as fast as Solana. I don't believe we are ever going to create something like the Move formal analysis prover. That's really cool technology. But we are going to focus on this 3rd dimension called features. And I'm going to quote this guy, Zen Lama. He says, speed and scale will no longer be a novel feature. What developers will be looking at are unique features at the execution layer. What are some things that can only happen on your chain and not in any other execution environment? That's unique features you're offering and innovations at the app layer. So we're doing both with Dango. We're building our infrastructure, optimizing for rich features, allowing to do many things that cannot be done on other chains, and we're building an innovative DeFi app. So back to the question, how do we prevent you from just running away with your collateral? Well, the account I mentioned is not a normal account. It is a smart account. It's a smart contract. Every single account on Dango is a smart contract. There's literally no such thing as an EOA or externally owned account in Grag. So how does a smart account work? Well, the smart accounts needs to implement 2 special functions. One is called authenticate. So if you send a transaction using that smart account, when the chain processes that transaction, it is going to call this function on the contract. Hey, we have this transaction. Could you please authenticate it? And you can implement whatever authentication logic you want in that function. It can be normal private keys. It can be pass keys. If you don't know, pass key is a secure key that is stored on your device, secure enclave, and you can use things like Face ID or fingerprint to send transactions. It can be EIP 712, which is the standard signature signing protocol in EVM. It can be a session key. If you don't know, if you go to Hyperliquid, you don't need to sign every transaction, right? You only sign with your wallet once when you log in, and later on when you place orders, do trades, you don't have to sign every transaction. That is because they use session keys. You can do that, or you can do on-order transactions. Just imagine if you broadcast 10 orders to the chain, you don't have to broadcast every transaction in strict order. You can out of order and still be secure. That is very necessary for a high-performance exchange. You can do all that. So after authenticate, we execute the messages in the transaction. So each message is roughly equivalent to a contract call in the EVM. So our transactions are natively multi-call, unlike EVM, when you can only do one call per transaction. And what really matters for our margin account is the last thing called backrun. So during authenticate, the account can optionally request to backrun the transaction. So what we do is after the user does all of those trades in the messages, we are going to backrun. After the transaction, we are going to compute the user's health factor. If you run away with your collateral, well, your health factor probably won't be very healthy. And if it's not healthy, we're going to reject that transaction and revert all these state changes that has happened. So that is how we prevent running away with your assets and safeguard the solvency of our lending protocol. I want to talk about two more features that we uniquely offer in our infra. The second one is cron jobs. So in today's blockchains, you only trigger a state change if you send a transaction. So no transaction, no state changes. And that's a big problem because a lot of the things that smart contract system rely on needs to be triggered at regular time intervals. For example, if you run a perp exchange, you might want to update your funding rates every 10 minutes or so. And you will have to have a bot submitting transactions to trigger that. And during network congestions, your transactions may not get in, and that's a huge problem. So in Dango, we have this feature called cron jobs. So what is a cron job? Well, I mentioned there is only state change if you have a transaction. Well, that's not true, actually, because let's just think about it. In a Bitcoin block, there is a state change that's not triggered by a transaction, and that is minting the block reward to the miner. That just happens automatically. That's not triggered by a transaction, right? And in Ethereum, there's a state change not triggered by a transaction. That is updating the base fee based on how full the blocks are, following EIP 1559, right? That's not triggered by a transaction. So these kind of things are called cron jobs. So these are things that are triggered by specific conditions, such as some amount of time passing. So we have cron jobs natively built into our infra. Any developers can specify whatever conditions they want to trigger their contracts. And our DEX utilizes this. Our DEX is a fully on-chain order book with frequent batch auctioning. So instead of settling your orders immediately as they're received, we pool your orders over a period of time, let's say half a second. And at the end of the half second, our contract is automatically triggered to match and fill those orders. And that largely, well, not completely, but largely prevents toxic flows and MEV. And another feature that we utilizes cron jobs is our passive liquidity provision. So we have a smart contract on chain that implements a market-making algorithm. And that market-making algorithm is triggered every block before the order matching to adjust its orders based on the latest Oracle price. And that prevents front running and guarantees a good yield on our passive liquidity pool. Another feature I really love, I like to mention, is we are actually a dual VM. We have a Rust VM, and we have a WebAssembly VM. Now, if you think about it, Ethereum is actually also a dual VM. You have the EVM bytecode, and you have precompiles. So precompiles are basically written in Go if you're running the Go client, or Rust if you're running Wreath, that is natively compiled into the chain's node software. So the problem with Ethereum precompile is they're really hard to write. They're not written in Solidity. They're written in totally different programming languages. However, in our case, you can program native Rust contracts or WebAssembly contracts from literally the same source code. The smart contract source code right there. If you compile that to WebAssembly, you can run that in Wasm VM. If you compile that, if you import that as a library into our chain, you can compile that into the chain as a Rust VM contract. So these contracts have exactly the same source code, exactly the same address space, exactly the same ABI. When you call a contract, you literally cannot tell whether you're calling a Rust contract or a Wasm contract. And by doing this, we observe a 20x more throughput. We are able to do a 40,000 TPS without any optimization like multi-threading or any smart database solution. Without any optimization, we can do 40,000 TPS on a single thread, and you can also do cool stuff like multi-threading in contracts. In fact, we are settling our orders in our order book in a multi-threaded way. Yeah, so in this talk, I mostly give you an overview of our project by telling you a story, right? How we get there, what was our motivation, what made us a good candidate for solving the problem. What I don't have time for today is to show you exactly what the app looks like, which is also packed with a bunch of innovations on the UX side. So I'm just going to briefly summarize this. On the DeFi side, we have an order book, fully on-chain with frequent batch auctions and passive liquidity provision. We're going to have a spot market. We're going to have a perps market. These two markets actually will cross-collateralize under our margin account. So you don't have to have a separate perp account, a separate spot account, and you have transfer assets between them, which is what you have to do on Hyperliquid. No need for that. On the infra side, we have hybrid VM, we have native smart account, we have cron jobs, we have bridges to BTC, to Doge, to EVM, Move, Solana. Block time, we can do 0.2, not a big issue, but we'll probably do 0.5 because that's what academic research suggests as the optimal time for batch auctions. So we're going to go with 0.5. We have Oracle feed literally every block submitted by our validators. On the UX side, we're going to be a walletless and keyless experience, so no need to install another browser extension, no need to generate C phrase. It's embedded in our web app. Our web app is going to be a multi-app, a super app. It is going to be hosting many other apps from third-party devs. It is going to have an app store, and we're going to have zero gas fee because you don't have to pay gas on Binance. You don't have to pay gas on Hyperliquid. And we believe we have to be on parity with those projects to be competitive. So zero gas fee. And that's it. Thank you.